Okay, so I thought let's see, where do I have this? I'm going to point you to this for that WebAssign question. I'm going to point you to this page 76 in the textbook, and this is about how can we use z-scores to determine unusual results in a binomial distribution. Well, Dr. Stevens gives you the formulas right there, so I mean they're not bad to use. And then he tells you this is a shortcut to unusual successes, and he's just using a z-score calculation, and that same two z-scores, either direction, more than two standard deviations either direction, we consider it to be an outlier or an unusual result. Okay. Now, one thing he kind of hides right here, and this is really very important. Let me get a pointer going here so I can color. Here we go. There's the spotlight. You see that right there? If you take the number of trials times the probability of success, that has to be greater than 5 or greater than or equal to 5. And the number of trials times the probability of a failure, 1 minus p, right? That also has to be bigger than 5. If both of these are not true, we don't have a symmetric distribution, and we shouldn't be using the mean, the standard deviation to talk about center and spread, right? That's something you learned back in chapter 2, chapter 3, and I tested you on that last test. Okay, so that doesn't go away. We're still going to hold that thought. So why does that work? Well, I did make another video about this, but let's go to here. I'm going to show you in Canvas the thing I'm talking about. So if we go to modules, and this is where that GigaCalc calculator is too. Here, it's under course resources, online statistical tools, and the GigaCalc calculator is this one you want. I'm momentarily going to show you this one to talk about why is that test important. Okay, so I think what was the one on the book here? Oh my, nope, not there. Oh, just a minute. Let me find it. Well, I guess I'll just make it up. I don't remember what it was. Was there 130 and the probability of success was 80? So 0.8. And then if I let it graph this, see how that's a nice normal distribution. And then if I did 20, because that's the probability of failure, that's also a nice normal distribution. Okay, so that's why n times p, n times q in this case has to be greater than 5. That gives me a normal distribution, and then times 8. What was it? 0.8. 0.8. That was also a normal distribution. Now you're probably saying, so what? Well, what if I only had 13? 80% of 13 is, well, that's more than 5 because half of 13 is 6.5, right? So what happens with that graph? See how that's not symmetric anymore? That's a right skewed or left skewed distribution. And if we do 2, I think it turns to a very right skew distribution. See, another right skew distribution. So you got to make sure those conditions, n times p and n times q, both have to be bigger than 5. So we get a symmetric distribution, so it's safe to use the mean and standard deviation. Okay, let me pause this and come back to a problem now. So this is on that same page down below the your turn things. Now we're still, this says has a can make, I'm having a cashew craving today, just so you know. That's why I picked this. So 60% of those nuts are cashews, and we're randomly selecting 20 nuts. Now, probability of success is 60 or 0.6, and we get n is 20. So to make sure, let's see, does Dr. Stevens do that here? No, he does do it here for got 6 cashews. You see how he did And so he did 20 times 0.6 and he got 12, and 20 times 0.4 and got 8. So both are greater than 5. We got a symmetric distribution, good to go. Okay. Now, because that held here, it's also held here. So let's do it. It's going to be the same mean and the same standard deviation. Maybe I should do those for you. So we already did, or Dr. Stevens already did the n times p to get the mean. Remember, the mean is the number of items, which is 20 in this case, times 0.6 is, and that's how you get the mean. And what did he get for that? He got 12. And then to get the standard deviation, we do that same calculation, 20 times 0.6 times 0.4. Well, since you've already multiplied 20 times 0.6 and got 12, 12 times 0.4, I think is 4.8. And then we can take the square root of 4.8, and I don't know what we get. What do we get? Just a minute here. I think I've got a, here we go. Here's my calculator. Come on. Come on, come on, come on. No, just a minute. Oh, let's see here. This computer is a little wonky with Zoom. I mean, it runs great. It's a school computer, but it runs great, but sometimes a little weird with Zoom. Okay, so let me clear this out. So what do we got? We've got 0.6. We got 0.8, 0.6 times 80. Oh, it was 4.8, wasn't it? I better do the math to make sure. No, times 20, not 80. Then times 0.4. So yeah, oh, it's a good thing I checked that because that's not 4.8. So 0.6 times 20. Oh, I did 20.4. Damn me. You gotta bear with me here. If I use second insert. There we go. Here, 4 point. And now I'll take the square root of that. Did you know you can take the square root of a number by raising to the 0.5 power? I don't know if you remember that from that in the algebra work. So that's the standard deviation. And now we're asking ourselves, is getting 9 cashews out of 20 unusual if there's 60% cashews in the can? So we'll just do the z-score. And here I'm going to use some parentheses. So 9 minus my mean of what was it? 12 divided by that standard deviation here. I'm just going to grab the whole thing. So that's a z-score of negative. I knew it was going to be a negative z-score because 9 is less than 12, but that's only 1 point, not even 1.4 standard deviation below the mean. So it wouldn't be unusual to get 9. What's the book asking us? How about 18 out of 20? Well, I probably already can tell that's going to be unusual. But here, let me come up and grab this. And I'm going to change that 9 to an 18. Let's see, delete. And I'm going to insert 18. I'm fast with these calculators, but I've been using them for years. So that's almost 3 standard deviations higher than mean. So yeah, that's definitely an unusual result. Okay. Now, what if this isn't normal? If this isn't a normal distribution? And so I need some other way to determine if it's unusual. Well, it's in the section where it's on that. But suppose it wasn't. If we can go out to that GigaCalc calculator. Do I have that open here? No, but I've got it right here. Let's go to the GigaCalc calculator. So if you don't have that normal probability situation going on, well, let's just do this. 20 and no, that probability is 0.6 and 20 trials, and we want to know 9 or fewer, right? So in that case, we do 9 or fewer would be this one. And see how that probability is more than 5%, so it wouldn't be unusual. That's what we found with the z-score. Remember, it was negative 1.3 3 something. So that wasn't unusual either. So this is what you do if you don't have a normal or symmetric, a normal distribution. We might as well start calling them normal distributions. Okay, so hope that helps. I mean, the shortcut works really well. And that's where honestly, that's where we're going to go after this next exam. We start talking about confidence intervals. We're going to be using the normal approximation, the binomial distribution. You'll learn about that next week. Okay, hope that helps.